We talked about graphing rational functions, and we talked about the first two squares. So today, I still didn't pull up the thing. Let me show you what they're going to look like. We're going to be in the third square, rational functions. I'm going to try to show you the three main types you're going to graph. Yesterday, they looked like this one, right? Yeah. Today, they're going to look maybe like that. Notice those two asymptotes, the blue asymptotes that are vertical there.
What's that?
There's another one. You might have some that look like that. Notice how it has a horizontal asymptote, but even still a piece of that function goes through it because the asymptote is bounding the two little wings on the end, not the middle piece. And that can happen. You also have one, I found it this morning. Oh, here's one. It could go that way or the other way. It could flip up or down, okay? One horizontal asymptote, no vertical asymptotes on that one. Let's see, there's three main types. The two with the ones with the two asymptotes with something in the middle. The little mountain looking thing that I just showed you. Okay, here's, come on, Stacy. Right there. See how that thing kind of does like a little check mark?
Why does that look like the Nike?
Like a little Nike check. That's what I call it. I call it the Nike graph. The blue is the graph, or the purple, not the blue, the purple, the magenta kind of color. You know? It's not like a parabola, it's like a slanted parabola or something. Okay, so I just wanted you to get a feel of what they're kind of going to look like as you graph it. Okay?
How many points are we going to add?
Don't worry about that. Don't worry about it.
A parabola is in an angle, that's why it's
I have a question.
Yeah.
Does the hop go like this?
Yes.
It's horizontal. Okay, so the hop goes like this and the bottom goes
Yes.
like horizon, right?
Yes.
horizontal. I was wondering myself. Every time you said that. I know what that was.
Or like, I thought I kept getting them mixed up because it's like, or like I wasn't getting the right point. I don't know. I was getting
Does X have an exponent in the top or bottom of the fraction?
Yeah.
Yes. So I am on the right side. Okay. Now. What do you mean both of them? Yeah. I'm sorry. Remind me as soon as I finish. All right. So step one: find the x-intercepts. So to do that, set the numerator, which is the top. And I number my stuff over here and I go, okay, the first thing I'm doing is x-intercepts because this one has a lot of steps to it. Okay, so x-intercepts, 6 equals 0. Well, wait. Is 6 ever going to be 0? Can you solve that for x? You can't solve it for x because there is no x. 6 is not going to be 0, so this tells me that there are no x-intercepts. So this graph is never going to cross the x-axis. But it'll never cross. Or maybe it's bounded and it doesn't, yeah. All right, step 2. Find and graph all vertical asymptotes. Here's your vase, Sally. Set the denominator, which is the bottom, equal to 0 and solve. X squared plus 1 equals 0. How do you solve that for x? Minus 1. Ooh.
It's imaginary.
It's I. We don't graph imaginaries on a number plane, right?
Wait, is it just, why is it not 1? It's just I? Because I is next.
Square root of -1 is I.
But if it was like square root of -2, it'd be 2i.
It'd be I times the square root of 2.
So there's no vertical asymptotes?
So there are no vertical asymptotes because I'm not graphing on an imaginary plane. I'm graphing on a real plane. Okay? So if you get an imaginary number or something that doesn't make sense, there are none. Everybody on track with me so far?
So wait, so why are there no x-intercepts?
Because to find the x-intercepts, you do the top to 0, and there's no x in the top. So it can't ever be 0. All right, step 3. Find and graph all horizontal asymptotes. Here's probably the most confusing part on here. You have to decide which scenario fits, A, B, or C. Okay? So look at what we're comparing. We're comparing degree of the numerator to the degree of the denominator, right? That means the biggest exponent up top compared to the biggest exponent down below. There's no exponent on top, so if there's no exponent, that means the exponent is zero, right?
Whatever one is the biggest exponent is the one you use.
Yes. If there was an x, if this was 6x, then it would be 1. But since there's no x there at all, the degree of the top is 0. How about the
So what's step 3? Like, wait.
horizontal asymptotes?
So if the degree of the numerator is on the top,
Yep.
it's less than the degree of the denominator?
Right. What's the degree of the bottom? 2. So if I were to put an inequality sign in between here, would it be less than, greater than, or equal to? Less than. Right? So which scenario am I in?
The numerator
Okay.
is
Were you
smaller,
confused?
So it's A.
All right, so the degree of the top is 0.
Okay. So
Is that where you're
but
confused?
you're getting the 2 from the square.
So it'd be A.
So we're in scenario A, yes. The degree of the numerator, which is the top, is smaller than the degree of the bottom. So what that tells me is that my horizontal asymptote is 0.
That's also that.
0. Y equals 0 is your asymptote. Step 4, make a t-chart. Here's where things get a little dicey, okay, because you have to pick enough points to pick up on the pattern. So what we're going to have to do is we're going to have to graph it, look at it, and now we have to decide what points and how many we need. Okay, so this is going to be a judgment call. I'm not going to say it's only going to be 2 on each side of the asymptote every time now. You might need 4 or 5 on one side, and you might need 2 on the other. You might not have a vertical asymptote, and you might just have to pick points. So you need to have enough points to pick up the pattern so you can draw a graph that is accurate. All right, so let's do y equals. And let's graph this. 6 divided by x squared plus uno. Do y'all need me to pause a second while y'all get set up? So let's graph it first. Let's look at what the graph looks like so we can decide what points we need to use. I'm going to zoom 6. It's a mountain graph.
Oh, mine doesn't look like that. It's
Did you put parentheses around your denominator?
No, we did that.
Okay, I put the,
So make sure your graph looks like mine. Sorry. Are we all good? Let's go to the t-chart. What do you think we should use? What are enough points that would give us enough that we could graph and get a good representation of the picture?
the one at the top. Was it
The one at the top, clearly the big one up there,
And
right?
then the ones where it like goes right by the x-intercept. That's like 3, negative 3, negative 3.
Okay. So you want to use -3, 0, and 3?
No, and the one at the top.
That's 0. That's when x. We're just looking for x values, and we'll
Oh,
plug
yeah.
them in and find the y, because we're doing a t-chart.
Yeah.
I did, because I know it's going to come down and hug that asymptote, I just did -1, 0, and 1. So long as I had that high point, I know. But there's not a right or a wrong to this, is what I'm getting at. But you do want to include that high point. So if you go into table, I did this. Maybe you want to do -3, 0, and 3 so you get a little bit better picture. You get a little bit wider on it, and that's fine. We'll do that since that's what Mel suggested.
So why do you do negative?
You want to get on either side.
So you do -3, 3, and what was the other one?
3. -3, 0, and 3. And I got 0.6, 6, and 0.6. So when I graph this, let's go through and graph each thing one thing at a time. Step 1 was x-intercepts, and there are none. Step 2 was vertical asymptotes, there are none. Step 3 was horizontal asymptotes, and there is one, it's y equals 0. And now we can just plot our points, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 6. 0, 6, 3.6, and negative 3.6. I wrote them right, but set them backwards. Come on. It doesn't have to be perfect, just clearly, because mine is not. How about domain?
Negative and positive.
Good job. It's what? Say it again. Close, really close. 0 to 6. I need a parenthesis on 0 because the point is on 6. Good job, y'all.
Wait, why are you doing, oh, because that's as high as it goes.
All right, so I get 2x squared over x squared minus 9, and so I want to graph. Yeah, x squared minus 9. So I'm still in the scenario of the third rectangle, and I'm going to work my way through. Step 1?
2, right?
Yeah.
Because it would be divided by the coefficient on the x, which is 1.
All right, step 1 is the x-intercept. So to find the x-intercepts, what do I do? Set the top to 0. 2x squared equals 0, then x equals 0. This graph is going to cross the x-axis at 0 at the origin, right? Step dos, that means 2. These are my vertical asymptotes. That's where the bottom goes to 0, right? Now, when you do the bottom to 0, how do you solve that? Add 9. What's the square root of 9? Or, yes, I have 2 vertical asymptotes.
Is it always going to be plus or minus?
If it's a square root, yes. Step 3.
Oh, because it's a plus or minus, I think.
Right. Which scenario? Is the degree of the top less than, greater than, or equal to the degree of the bottom? Equal to.
Yeah.
Degree, not leading coefficient.
I didn't put a 2 at the top of the 2x.
So they're equal, which means I'm in scenario B, which means that the horizontal asymptote is the same as what we were doing when we had a similar scenario yesterday where we did a ratio of the coefficients.
2 divided by
Which is 2. When these are equal, you just take these two numbers and divide them.
Like if it's greater than the bottom one?
If it's equal.
They're not
The degree, the exponents.
Oh, okay, wait, hold on.
So what if it was like 3x squared over 2x squared?
They're still equal, so it would be 3 over 2.
2x.
Over 2x, then that would be a greater than scenario, so you'd be in scenario C on your paper.
Wait, so when exponents are equal,
So when
use the when exponents are equal, use the bottom, the top and the bottom.
The leading coefficients, yeah.
But it's just exponent that's on x, right? So like if you have one line, it wouldn't add.
That's correct. It's the biggest exponent on the x, right? All right, let's graph it. Be very careful with your parentheses on these. Y equals 2x squared, nope, divided by x squared minus 9.
Is it safer just to put them all in parentheses?
I would to make sure. Is everybody done with it? There you go. Doesn't matter. Thank you. Some of you, your calculator will actually graph the asymptotes, and so it may have a little line between here and here. All right, so I'm thinking my asymptotes are at -3 and 3, right? What kind of x values should I pick? 4 and -4, definitely. And I need at least 2 on that side because I'm going to have to get this whole little wing here. So let's do -4, -5, +4, +5. And I also need to be able to pick up that little mini parabola in the middle.
I have 2 lines.
-1 and 1, because you've already got 0 because it's an intercept, remember? Yeah, yours is just graphing the asymptotes. That's okay.
So you do it off each line?
All right. Let's find these points. Let's do -4, -5, 4, 5. What do you notice? What else do you notice?
It's like, great.
No, I'm
They're
not.
the same numbers, negative or positive.
They are. What does that tell you about the graph?
That is
symmetrical.
You can probably trace on that one and give you some exact numbers. Just scroll. So yes, 4.57, 3.13, 4.57. So what we were saying is that means that it's symmetrical on both sides. -0.25. Okay, so make sure, and that you don't have to use the exact points that I use. Make sure you use something that gives you enough to pick up the pattern there in the graph.
So how would you guess what the x is?
I looked at the graph. I know that the asymptote is 3, so I know I need to go on either side of the asymptote. So on my graph, I picked up 2 this way. I wanted to pick up this -1, 0, and 1 because it's that parabola. And then 2 over here, yeah. All right, let's graph it and see what happens. Ain't nothing to it but to do it. X-intercepts, 0. Vertical asymptote. That's right.
There's 2.
There's 2. I did not leave enough room for my graph. This sucks. Oh well. Okay. -4. 4.5. 1, 2, 3, 4, 5. So about right here. And then -5. A little above 3. This is my asymptote, by the way. I'm just plotting these points, y'all. It's just a lot of points to plot, really. It's tedious. 4, 4.5, 5. Don't be so excited. What? Yeah. -1, negative a quarter, 1, negative a quarter. All right, so I've got them all plotted, and I'm just going to connect. You know what it looks like. You graphed it on the calculator. These asymptotes are bounding these wings. I call them wings. I don't think that's the appropriate term for them, but. And then.
Will be 3 domains?
Yes. Stop using purple and orange. All right, domain. All right, here we go. Oh, I wish I had a good place to write it. I'm gonna just come right here. Domain. Negative infinity. All right, I'm going left to right, right? What stops me as I move to the right? Negative 3, right? I'm trucking. Oh, stop. Asymptote at negative 3. But it picks back up after that, right? So negative 3, and then to positive 3. Bless you. And then it picks back up with 3 to infinity.
Oh, I forgot about that one.
Yeah.
So, what about the one on the bottom?
You look at it as a whole.
Wait, so it has to touch the origin, like
Range is a little bit trickier here. Okay, so what, well, kind of, no, not for this one. All right, it goes down forever, so that tells me I start with negative infinity. Now start going up, and I'll hold my pencil a lot of times like this. And just take it up. Where does the graph stop? Where do you stop having graph? At 0. Look, from here to here, all this space has no graph in it. Do you agree? It never will have any graph in it. Do you agree? So from negative infinity up to 0, can it be 0? Right? That's the intercept. And I'm going to join that. Now it skips all that space, so don't include it. Where does it start picking back up? At 2. Does it include 2? It's an asymptote. It's an asymptote. It's dashed.
Wait, so the point can't be on the asymptote?
No. The point will never be on the asymptote. So if you have a physical point, it's a bracket. If you have an asymptote, it's a parenthesis. If you have an asymptote dashed, it's a parenthesis. But if you have an actual point there, it's a bracket. Last one.
Wait, can I write down the name?
Yeah.
Wait,
X-intercepts are the top, equal to 0. Oh my goodness, y'all, look.
No.
Yes. It's a quadratic formula. It's not a quadratic formula because this one's factorable.
And that's what I'm saying, so it's gonna be more than one. So
Yes.
it's negative 4, and that would be
4 and 4.
yes.
Negative 4 and 1.
Yes.
So where does it cross the x-axis?
4 and negative 1.
What? Don't remember what? Factoring?
This is we're not gonna say anything about that.
If you leave this class and you can't factor, you have not been sitting in this class all semester. There is no way you can see something done that many times and not be able to do it.
Like, what do you do with the ones where it's 4 exponents? I mean, 4 of those things.
Slash.
You just slash through, but
Wait, what
it
do you-
doesn't work sometimes.
Yeah, what do you do if it's like that and the third number is
PRZ.
bigger than the
Then you
fourth?
multiply it by each other?
You'd have to PRZ it to factor it.
Oh yeah, that's what I asked. I forgot how to do that.
Because there was a lot of problems where it was like, it would have been like 18 and then 4 behind it, so the third number was bigger than the other.
Va's at the bottom equal to 0 because the denominator cannot be 0. That is undefined. That would give us a vertical asymptote. So the vertical asymptote is x equals dose. That means 2. Number 3. Clearly, I hope you know which scenario we're in because I told you there was 3. I told you we were going to do 1 in each scenario. We've done 2. Oh, C, that's right. The degree of the top is bigger than the degree of the bottom. It is top heavy.
You just take the top one?
So if that's the case, look at option C. If the degree of the numerator is greater than the degree of the denominator, then there's no.
Alright, slow down.
No, slow down.
Forget to record here. Okay. There it goes.
Yeah, we're better than the first one.
X squared plus 3x minus 4 divided by x minus 2.
It's only one, I think you're recording again.
There you go.
Wait,
You
so
have to
You
what?
have to have the parentheses before.
Yeah, mine didn't do it.
Yeah. What were you saying, Natalie?
Like, I have to post graph and then graph it post
And then table.
there she is.
So it looks like there is only one piece, but we know those Nike checks are a little tricky.
Change your window to.
I'm gonna take the Y up. What'd you take it up to? 25 maybe? But you gotta change it.
Take the one like 30.
Change your Y max to 30.
Wait, why was your Y max?
How you do that?
Hit window. Now you can see both pieces.
Oh.
All right. Now listen, for the sake of time, because class is just about over, on this one, I would choose, when you choose your points, okay, this is one that's a little bit tricky because I need to choose at least enough points to where I can get enough of this graph to get it going down and back up, right? So I would pick at least enough to get this area and this area in the, right, on either side.
Yeah, 3 points.
What is the domain? Now remember, my vertical asymptote was what here? What was it, 2 or 3? 2. So what's the domain?
No.
Negative infinity, 2, 2.
You, 2. There's no vertical asymptote.
The range is a little different because here's what you have to do. You have to take the highest point here and the lowest point here because in between here there's not any graph and there never will be. Because this starts shooting back up and this starts shooting back down. So I need to leave this out of my range, right? So, negative infinity up to 0. It goes a little bit above 0, but that's okay. You'll see it when you graph. You just need to estimate. I'm going to combine that with, now it needs to pick up about right here. I don't, if anybody's on the graph, what does it, can you trace it and see what it goes down to? You could actually calculate the minimum. Second trace, min. Somebody let me hold a calculator.
There you go.
It's not mine.
No, that's not trying to do it right now. Hampton, you don't even have this one in there. What's the equation?
Mine's right here, ready for you.
Did you already calculate the minimum? Is that the minimum?
Hey.
I mean, you don't have to do the X, Y, now.
All right, this minimum is actually occurring at about 12. That's up. This point is like 412. This point is. So from here, it's going to go negative infinity to 0, and then it's going to pick up at 12 and go to infinity.
How did you do that? You had.
I calculated remember how we calculated maxes and mins and zeros. I went second trace and calculated the minimum right there for that one.
How
Yeah.
did you
Are
calculate
you
that?
gonna make us graph the graph like that?
Yes.
Like with the bunch of
Wait, go
numbers
back to
on
the
it?
domain.
With 12?
Oh, it's gone.
Negative infinity to 2. Just so you see, this is what I did on Matthew's calculator. I'm going to jump over to the other.
How do you get over to the other one?
Just keep going over.
I have 4. I got 412.
I just rounded it. I just rounded it just for the sake of example. I picked the minimum there.
Good afternoon, Canaan High School. It's Friday.